So this is problem 6.2.11. We're asked to sketch the region and find its area. The functions that you're given are y equals e to the x, so just the exponential, y equals e to the x, and then y equals e to the negative 2x, which is a decay of, it's over on the left-hand side. And the third piece of information, which helps put boundaries on this region, is x equals ln of 5. So let's look for the limits of integration here, and they are given to us. So we're fortunate. It depends on which way we want to integrate, and we're going to integrate with respect to x, because if we integrate it with respect to y, we have multiple regions. So we're going to integrate with respect to x, and x is going to go from 0 to ln of 5 because of what we know of where these two graphs intersect. They're going to intersect at the point x equals 0. So let's set up the integral. It's going to go from 0 to ln of 5, and then we need to determine the curve on the right and the curve on the left, or I'm sorry, since we're integrating with respect to x, the curve on the top and the curve on the bottom. And in this case, e to the x is f of x. This is the curve on the top, and the curve on the bottom is e to the minus 2x dx. So that's the setup for the integral. Now, take the antiderivative of this. I'm going to split it off into two integrals because I think that's a little bit easier for you to see. And I'm going to write it like this. The first one is pretty straightforward, right? The integral of e to the x is just e to the x. So the answer here is e to the x. Over here, you've got to do a little work. We're going to let u equal negative 2x, and du is equal to negative 2 dx, right? And we can, just in case you're still not comfortable with the direct substitution, you get minus du is equal, dx is equal to du over minus 2. So let's go about and substitute here. And I haven't evaluated this one yet. We'll come back to that. So we've got du equals, or dx equals du over negative 2. And I've got a negative sign here, and this is e to the u now. So I'm going to cancel out and pull the 1/2 out front, and I'm left with e to the u du, which is simply 1/2 e to the u, which is 1/2 e to the negative 2x. Okay, so we've got antiderivatives here. We've got e to the x from this one, and we've got 1/2 e to the negative 2x from the one on the right, and we're going to evaluate it between 0 and ln of 5. So e to the ln of 5 plus 1/2 e to the negative 2 ln of 5 minus e to the 0 plus 1/2 e, and then substituting in 0 for x, you get e to the 0. Okay. So we're left with this algebra to resolve in order to get an answer. And you may or may not recall all of your log and exponential relations. So let's go through that. I need to pause here for a minute, excuse me. So let's finish off the algebra here, and e to the ln of 5 is equal to 5 plus 1/2 e to the ln, or e to the negative 2 times ln of 5. If you move this up to your exponent, you're left with e to the ln of 5 to the negative 2, which is just 5 to the negative 2, And 5 to the negative 2 is just 1 over 5 squared. Minus e to the 0 is 1, plus 1/2 e to the 0 is 1/2. And when you work this out, you get 5 plus 150 minus 3/2, get a common denominator, and you end up with 250 over 50 plus 150 minus 75 over 50. All I did was just get a common denominator, and I'm left with 176 over 50, which reduces down to 88/25. And that's it.